All right, here I'm going to show you how we use Lewis structures to represent ionic bonds. Recall a Lewis structure is simply the name of the element, or the element symbol, so something like, say, oxygen, O, and then we put just as little dots the valence electrons that that atom would have. So that would be oxygen, and it's 6 valence electrons. We can tell how many based on the column that it is in the periodic table. When we want to actually show the bonding, we can do it in two ways. We can show the transfer of the electrons, or we can show the final Lewis structure, usually for one formula unit. So I'll give you a couple examples of those. Lithium oxide. Lithium has 1 valence electron. Oxygen has 6. So there's 6. And to show the transfer, what I do is I put an arrow showing where the electron's going, and then I put an X to say that it's transferred out or it's away from that one. Now what I can see here is that oxygen is now at 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. And we can see then that it still has the ability to attract in more electrons. So I'd have to add another lithium here, and his 1 electron. And I could show that transferring over to the oxygen as well, putting an X where it was and a dot where it is now. And that shows that it requires 2 lithium atoms with 1 electron each to satisfy 1 oxygen atom, which has space for 2 more electrons going from 6 to 8. No more lithiums are required because oxygen would have to start a new shell if it took another electron, and obviously it doesn't want to do that. The final Lewis structure shows the final overall charge of the actual elements. So lithium here has an overall charge of +1, having lost 1 electron. So we can say 1 plus. And we can see that there are 2 lithiums in a formula unit, or in the most basic repeating unit of the lithium oxide crystal. And so we put a 2 at the bottom to indicate the number of lithium atoms. For oxygen, again, we put square brackets around ions to keep them separate. We put the 8 valence electrons in this time to show that it's taken in those 2 extra electrons, and as a result now has 8. And when it took 2 extra electrons, its charge was 2 minus. And we don't have to put a 1 here, it's assumed if there's nothing there. So we can just leave that like that. For any ionic substance, the overall crystal has to be neutral, and we can check that that's the case here when we have 2 plus 1 atoms and 1 2 minus atom. We can see that our overall +2 minus 2 adds up to 0, and that this element is neutral. So that's lithium oxide. We can do magnesium chloride. Mg would have 2 valence electrons. Cl, or chlorine, would have 7 valence electrons. It's a halogen. And here we can see that chlorine will take 1 of magnesium's electrons. Unfortunately, chlorine can't take both, so we need another chlorine atom. And again, we transfer the electron. X over where it was, dot where it's gone, and there we see the transfer. We see that it requires 2 chlorine atoms for every 1 magnesium atom. And if I want to write the final structure, again, I put my ions in brackets. We go 2 plus instead of +2 here. I don't really know why, but that's what they do. And then chlorine, with its now full 8 valence electrons, its charge of 1 minus, and we need 2 of them to make it complete. Again, I don't have to put the 1 here, it's assumed. Checking the overall charge on this molecule, I have 1 plus 2 and 2 minus 1s. And so I add up to 0, and I have overall neutral crystal. And these ions stick together because they have opposite charge, and they would just build into a giant crystal that's held together through that electrostatic attraction. So that's the transfer diagram and the final Lewis structure.